So as a continuation of our discussion on exponents, you're assigned to do 1 through 29 odd. So I'm going to go ahead and do the even problems. I'm not going to do all the even problems, but hopefully enough of them to at least jumpstart that conversation we had a few days ago, and as well as the conversation we've been having for the last couple of weeks as part of our getting started problems at the beginning of class. So in the first problem, we have two bases, a 2 and an m. With the 2, there's only one 2. There's no other 2's that we're going to be multiplying to that. So 2 stays the same, and then the exponents on the m's get added. So we're looking at a 4 to the m, m to the 4 plus -3. So that ends up with 2 times m to the first power, or simply 2m. Keep in mind that they want all the answers to be positive exponents, so in this case here the m ends up being a positive. The next problem we have 4 times 2 times, in the end we have also 4 plus -3. So we have 4 times 2, which is 8, and then 4 plus -3 for the addition problem, which gives me a positive 1, so 8n will be the final answer. In problem 6, we definitely have 2's, we have x's, and we have y's. For the 2's, we have 2 of them, so we have 2 with 1 plus 1. For the x's, we have 3 plus -1. And for the y's, we have -3 plus 3. We add the exponents. So the final exponent on the 2 is the second power. The exponent on the x will be 2. And the exponent on the y, because we have a -3 and a 0, plus a 3, we get a 0. Just a reminder that anytime we have something raised to 0 power, that's going to get replaced with a 1. So the problem becomes 2 squared times x squared times 1. So the final answer is 2 squared times x squared. Now there is an answer key. You want to provide the answer key for this activity. You'll notice that for this problem here, number 6, they went ahead and multiplied the 2 times 2 and made it a 4. So just be aware that, depending on the worksheet and the author, sometimes they will go one step further and simplify that number that has an exponent to it. So both 2 squared or just simply 4 are both acceptable answers. So jumping down a bit, let's look at number 10. We have an x base and a y base. Why don't you go ahead and do this one? I think the answer is going to be. So the exponents on the x get added as well as the y. So the exponent of the x is 5, and the exponent of the y is -2. So we've been talking about this idea of a negative exponent. So that tells me that those y's really are in the denominator of our answer, and the x's remain in the numerator because the exponent's positive. So the final answer is x to the 5th over y squared. Talk a little bit about the fact that if I had a problem like 3 y's in the numerator, for example, 5 y's in the denominator, if I was actually doing this problem as y cubed over y to the 5th, the rule that we've been using is we subtract the exponents, so that becomes y to the 3 minus 5, which is y to the -2. But if I actually simplify the problem by making 1's, what I end up getting is 1 over y times y, or 1 over y squared. So y to the -2 is the same as 1 over y squared, because the -2 is telling me that those y's, if I had a problem like this, the leftover y's are actually in the denominator, not in the numerator. Let's take a look at problem number 12, and then we'll look at also 14. So problem number 12, we're multiplying by the exponent of both the 2 and the x by -4. So it's going to be 2 to the 1 times -4. And for the x, it's going to be 2 times -4. So the exponent on the 2 is going to be -4, and the exponent on the x will be -8, 2 times -4. Both of the exponents are negative, which tells me that the final answer is going to be 1 over 2 to the 4th times x to the 8th, since both exponents are negative. We go ahead and take a look at 14, and then we're going to jump down to 18. We're going to do the same thing. We're going to multiply through by the 2. The exponent on the 4 is a 1, so it's going to be 4 to the 1 times 2 times a to the 3 times 2. So it's 4 cubed times a to the 6th. Exponents are both positive, so that means that they remain in the numerator. So take a look at problem 18, and then we're going to jump down to problem 22. Go ahead and complete both 18 and 22, and then turn the video back on. So in problem 18, we're multiplying the exponents both by 2, so it's going to be x to the 2 times 2, and the y is going to be -1 times 2. So we end up with, for the x, it's going to be x to the 4th, 2 times 2, and y is going to be y to the -2, because of -1 times 2. So the x to the 4 stays in the numerator, where the y goes to the denominator, making the exponent become y squared. In problem 22, the 4 itself, we're not doing anything to it because of the fact that there's just one of them. But for the x's, if we have a fraction, what we do is we subtract the exponent, so it'll be -1 minus 4. So it becomes x to the -5 over 4. And because the exponent of the x is negative, that means that the x will end up in the denominator, and the exponent becomes +5. So the final answer here is 1 over 4 times x to the 5th. If there had been a 4 in the numerator, then we would have subtracted the exponent from the 4's again, also. For example, let's say I had 4 cubed, x to the -1 over 4 times x to the 4th. Since the exponent on the 4 in the denominator is a 1, it becomes 4 to the 3 minus 1 times x to the -1 minus 4. So the 4's exponent would be 2, and the exponent on the x would still be -5, -1 minus 4. So the final answer here is the 4 would still stay in the numerator because the exponent is already positive, where the x will go to the denominator because the exponent is negative. So you may be asked to do, like in problem 23, for example, problems in where you have both a number in both the numerator and the denominator. So let's jump down to 26. So in problem 26, and what I would suggest is doing 26 as well as 28 and 30, is you first look at the numerator and as well as the denominator and see if you can simplify the numerator. And so we have 2 and x of y and a z. So we don't have 2x's in the numerator or 2y. So there's nothing in terms of adding those exponents. And the same thing is true in the denominator. We have an x, a y, and a z, and a 3. So there's no way of, again, using our exponent rules to make the denominator simpler. So what we're going to do is we're going to use our exponent rule for fractions. So the 2 and the 3 are not going to change because there's nothing we're doing to the 2 or the 3 since there's one of each. But for the x, we're going to subtract the exponents, 4 minus 2. For the y, we're going to subtract those exponents, -4 minus -3. And for the z, we're going to subtract the exponents, negative 3 minus 4. So 2 stays in the numerator, 3 in the denominator. For the x, when I subtract the exponents, I get a final answer of 2, 4 minus 2. For the y, it's negative 4 minus negative 3, so that's negative 1. Again, if you struggle with the integers now, use the calculator and just put in negative 4 minus negative 3, hit return or enter and get your answer. And then for z, if I take negative 3 minus 4, I get negative 7. So for the final answer, the 2 and the 3 both have an exponent of 1, positive 1, so they're going to stay right where they're at. The x squared already has a positive exponent, so it's going to stay in the numerator. But the y and the z have negative exponents. The y goes down to the denominator, becomes y to the first, and z becomes z to the seventh. Let's take a look at problem 28. I want you to go ahead and take a look at it on your own, turn the video back on when you're finished. So like the previous problem, the 2 and the 3, there's only one of them, so therefore they're going to stay right where they're at since the exponents are both 1. For the h, there is only one h in the numerator, so there's nothing we're going to be doing with the h's. For the j, we have a j in the numerator and a j in the denominator, so it's going to be negative 3 minus 1. Because the exponent on the j as well as the k in the denominator are both 1s. And then the k, we're going to subtract 4 minus 1. So the numerator is 2, the denominator is 3, that doesn't change. H still is going to be cubed. The j, we're subtracting the negative 3 minus the 1, so that's a negative 4. And then the k is 4 minus 1, which is a 3. So for the final answer here, the 2 and the 3 are, again, stay right where they're at. H, the exponent's positive, so it stays in the numerator. The k is also positive, so it stays in the numerator. And then the j gets moved to the denominator since it's negative in the numerator, which means those j's would actually be in the denominator. So final answer would be 2h cubed, k cubed over 3j to the 4th. So your assignment is to complete the odd problems. Again, we're just using those basic rules for exponents. We either have a multiplication problem, we're adding them, we have parentheses, we're multiplying, we have a fraction, we're subtracting. Next week we will introduce the remaining exponent rules, and then we'll get into more work involving solving equations with exponents as well. As I mentioned also, there is an answer key at the bottom, so I've provided the answer key in hopes of you being able to check your work, and at least be able to feel like when you come in on Tuesday of next week, if you have any question on the homework assignment, we can address those problems that you couldn't figure out.